Hello. The topic of discussion for the day is area related to circle. A circle has certain factors associated with that. One of the parameters is the circumference of the circle. What is the circumference? Circumference is the distance that you have to travel along the curved path or along the boundary of the circle. So if you start from here and don't get inside the circle, don't go outside the circle, just walk along the boundary of the circle. Then the distance that you have to travel is called a circumference. And that circumference is equal to 2 pi r. The area of the circle is this area that has been covered by the circle or that is inside the circle. And this area is equal to pi r square. This value pi is a specific constant and its value is 3.14, or you can also take the value of pi equal to 22 by 7. Although pi is not exactly equal to 22 by 7, the value of pi is a non-recurring infinite number, but the value is very close to what would be the value of 22 by 7. So sometimes we take it as 22 by 7, but it is not exactly 22 by 7. However, in some examples we take the value 3.14. In some examples we take the value of pi as 22 by 7. Whenever the radius is multiple of 7, then multiplying by this value is better. Pi, using pi as 22 by 7 is better because 7 and 7 will get cancelled. Otherwise, using 3.14 is obviously an option. In some problems in the examination, it is specified that take pi equal to 3.14 or take pi is equal to 22 by 7. In that case, you have no choice but to take the specified value. You don't use your mind then and choose some other value. You only use the value that is given. But if it is not given, if it is up to you, then you can choose either of these two values. Anyway, so the circumference, the formula is known, 2 pi r, and the area is also known. Supposedly, the given circle is not taken as an entire circle, but only a part of it is under consideration. What it would be like? Let's see this. So I am talking about only a part of the circle. How? Like this. O is the center. AOB would be is part of the circle. O is the center. So AO and OB are the different radii, and theta is the angle between the two radii. This is what we call a sector. This entire thing, this entire thing is called a sector. The area of the sector, I will write minor sector, or rather we can simply write sector. Area of the sector is equal to theta upon 360 into the entire area of the circle, pi r square. If the value of theta is known, if the value of radius is known, you can put the value and you will get the area of the sector. There are two sectors here. This is the one sector, this is the first one. And there is one more sector possible, that is this one. This is called as minor sector, it's a smaller one. This is the major sector. So the area of the minor sector will be theta upon 360 into pi r square, where the value of theta is this angle. Major sector, area of major sector will be theta upon 360 into pi r square, where the value of theta would be this angle. Sometimes the students prefer the formula that area of major sector would be written as 360 minus theta. It is okay, but in the value of theta, you got to take it as an acute angle. Not acute, even less than 180 degree it should be. But then why complicate things? Just theta upon 360 into pi r square. The value of theta, if the theta corresponds to this smaller angle, this angle, if theta is less than 180 degree, you are obviously talking about the minor sector. If the value of theta is greater than 180 degree, then you are talking about the major sector. Take the appropriate angle theta, you will get the answer. Not only that, but in this case, if you talk about this, then there is also this distance involved, and this is called as arc length. Arc length is length of the arc. What is an arc? A part of the circle or a part of the circumference, a fractional part or small part of the circumference is called as an arc. You start from A, you reach B. This is along the circumference of the circle, but you have not traveled the entire circumference. You only covered a part of it, a bit of it. Then the length of the arc is equal to this angle theta. So you backtrace these from here, you join to the origin, to the center. From here as well, you join to the center. The angle subtended by these two radii is theta. Then you put that arc length is equal to theta upon 360 degree into 2 pi r. This would be the formula for the arc length. The total arc length would have been 2 pi r if this angle theta, this entire angle was 360 degree. If you started from A and you covered back to A, so the entire angle will be 360 degree. So it is 360 upon 360 is 1 into 2 pi r is the entire circumference arc length would be. If the theta is 180 degree, then it is half of the circumference. It is called semi-circumference, or actually half of the circumference. It would be 180 upon 360 is 1 by 2 into 2 pi. And so on, we can derive many other logics from this. But we basically have an area of sector, an arc length, and there is one more thing that we can actually get, and we will find that. So we will, if I join from this A to this B, A and B join this area. So whenever we have, if we join A to B, then we are actually basically dividing this entire circle into two different parts. The AB, this side AB or this length AB is basically the chord of this circle, chord, and this chord is cutting the circle into two different parts. They are not equal parts, but there are two parts. One part is this, only this, and the other part is also this. The distance or the area between the chord and the remaining circle. The area between the chord and the remaining circle. There are two different areas possible. This is called a segment. So this is one segment. This is called as a minor segment, and this would be major segment. So we also get a segment. This is the minor segment because it is corresponding to the minor sector. And then there is a major segment. This is the major segment, which the area will correspond to the major sector. To find out the area of the major segment, you first have to know the value of the area of minor segment. How do you find out the area of minor segment? I will write area of minor segment is equal to area of sector AOB minus area of triangle AOB. So this entire sector wala area, sector's area minus this triangle's area will be equal to this area. This is the minor segment, area of the minor segment. If you know the area of the minor segment, then from the entire circle, subtract this area, you get the area of the major segment. I hope you understand this. Major segment will be this. The area of major segment will be entire this. This entire area is equal to circle area of the circle minus this area, minor segment. So we first find out the area of minor segment. How do you find out the area of minor segment? Find the area of the sector, subtract the area of this triangle from the sector. You get the area of the minor segment. Then from the entire area of the circle, subtract the area of the minor segment, you get the area of the major segment. Area of sector can also be determined like this. Minor sector, you find out the area of minor sector, and from the entire area of the circle, subtract this minor sector's area, you get the area of the major sector. Circumference also you can do that. Find out the arc length of this minor sector. So this arc length would be equal to circumference minus smaller arc length, minus the arc length of the minor sector. Sometimes the questions can come like, it is given the AOB is a sector and find out the arc length and area associated with the major sector. So arc length is also associated with the major sector. So the question is talking about this distance, this arc length, and this arc length is equal to, either you find out this angle and then put the angle here, that larger angle, the bigger angle, put that here upon 360 into 2 pi r, that will do, or you find out this arc length in the formula, smaller angle upon 360 into 2 pi r will be this arc length, and from the entire circumference subtract this arc length, you get the arc length related to or associated to major sector. Area of major sector you can always find out, put this angle here upon 360 into pi r square, you get the area of the major sector, or find out the area of the minor sector and from the entire circle's area subtract this area of the minor sector, you get the area of the major sector. For finding out the area of the segment, there is no choice. You have to find out the area of minor sector, then this triangle AOB, subtract the area of the triangle from the sector, you get the area of minor segment, and from the area of minor segment you can actually calculate the area of major segment by subtracting this area of minor segment from the area of the circle. This is all that we have in this chapter. I want you to just see this video, revise it once, and then take any, if you have R.D. Sharma with you, use R.D. Sharma, or take help of any online website which will give you the important questions based on this chapter. Just study this. My laptop needed some repair, so I sent it for repair. I am hoping the shop owner has promised me, the service center guy has promised me that I'll get my laptop tonight. So if I get it back by tonight, it is great. I'll just tonight itself I'll make all the worksheets, because I had made a couple of worksheets to send you, but before that the laptop had some issue. So if I get the laptop, I'll immediately send the worksheet. If I don't have the laptop immediately, please keep practicing from any resource that you can get and solve the previous board examination papers or previous board examination questions from these chapters. I hope you like this. I hope you understand this, and I hope this is helpful for you. Just keep studying. All the best.